All right, guys and gals, so now let's talk about Bronsted-Lowry acids and bases. This is a little bit more of a broad definition of acids and bases. So let's just talk about what they are first. Let's start with Bronsted-Lowry acids. So I'll write Bl acids, Bronsted-Lowry. So what is a Bronsted-Lowry acid? It is anything that donates a proton.
Okay, so the other ones we talked about, the Arrhenius acids, were just hydrogen ion donors.
Well, they didn't necessarily donate it, or they produced the hydrogen ion. So this one is actually where the acid is donating that H plus ion. And by the way, when we say proton, when we're talking acids and bases, we just mean a hydrogen ion, H plus. Okay, so anything that will actually donate that proton will be an acid, and conversely, a Bronsted-Lowry base is anything that accepts a proton. And again, a proton is H plus. So proton donor, proton acceptor, acid, base. This is a lot easier to see when we actually look at a reaction.
Okay,
so
let's do that.
Let's look at one here. So let's say we have NH3, ammonia. We mix it with water. And what we get is an ammonium ion and a hydroxide ion. Okay, so obviously, since we see some ions on the right side, there was some sort of changing of ions. So what we have to do is figure out who donated the proton of these guys over here, who donated the proton, and who accepted the proton.
Okay, well, it looks to me like NH3 accepted.
Okay, so NH3 right here, if we move from here to here, it got an extra hydrogen.
Yep.
See, it has 4, used to have 3. And so it accepted the proton. So we will say that NH3 ammonia is the Bronsted-Lowry base.
Because it was the acceptor.
It accepted the proton.
Okay.
Well, who did it accept the proton from?
Water.
Water. So in this case, water, let's use the box. Water, since it went from H2O to OH minus, it lost that H plus.
Okay.
So it donated it to ammonia. So then we would say that H2O is the Bronsted-Lowry acid. Okay, so as you can see, this guy donated a proton to that guy. And that's pretty much what happened. What happens if H plus goes away from H2O? You've got OH minus left over. Should be pretty clear. The other thing we have to talk about, though, is this concept of conjugate acid and conjugate base. So what I'm going to do is, bear with me here, I'm going to rewrite this so we can have a nice clean slate. Okay, so we know that this is the base and this is the acid. So what happens after the acid donates the proton? It becomes this guy right here. After the acid donates a proton, it becomes the conjugate, hopefully I can fit this, the conjugate base.
Okay, because it would need to accept a proton now.
Yes.
Okay.
So the acid becomes a conjugate base on the right-hand side.
Just its pair.
Right. And so then the ammonium ion here on the right would actually, since it started out as a base, it is now the conjugate. Opposite of base is acid. So as you can see, that base became a conjugate acid because now it has a proton that it can donate.
Yep. It
So
went back the other way.
So the base becomes the conjugate acid, and the acid becomes the conjugate base.
Easy enough.